Hi everyone, in this video we're going to talk about integration by parts. So what I have at the very top of my sheet here is just the integration by parts formula. So the integral of u dv equals uv minus the integral of v du, which is kind of shorthand for the full formula, but it's enough for us to get by. So we're going to do two examples in this video. The first one is the integral of 3x sine of x dx. So when I look at this, I might think like, okay, there's a lot going on here. I don't have a basic integral rule for this function, so that's out. I can't do substitution because, for example, sine of x, if I sub in for that, its derivative cosine of x isn't there. So it's a perfect candidate for integration by parts because it's the product of two things that we have rules for. All right, so when we start with integration by parts, I usually just write this out first. I need to decide what u, v, du, and dv are, and then plug them into this formula up here. So what we're going to do is kind of break this integrand into two pieces, u and dv. So these are the two pieces that actually get filled in, and then the other two get computed. So I can put either 3x here and sine of x here, or sine of x here and 3x here. That's kind of the natural way that they break up. I'm going to choose to do this. And I'm actually going to write the dx in this spot right here. You'll usually see the solutions in the textbook written that way as well. If you skip this dx and then you skip the dx down here, you're not wrong, but it's technically polite to include that there. Okay, so first thing I want to make sure of is that 3x, or my u times my dv, so this times this crap, really is the original stuff I started with, so we're good there. Now, the reason that I put them in these spots instead of vice versa is that the derivative of 3x is just 3, and I'm actually going to say dx to be polite, but if you just write a 3, you're probably fine. So this derivative is better than the original function. So when we get to the integral of v du part of our formula, we're going to really want that new integrand to be somehow better than what we started with. So either this derivative has to be better or this antiderivative has to be better. And sine, no matter which direction we go, you're just going to get some kind of cosine, right? Like it's not going to get any better or worse. So we needed this one to get better here. Okay, so I took this guy's derivative and computed a 3. Now I want to compute the antiderivative of sine of x. So I'm kind of doing like a mini integral right here to fill in my spot. So I'm going to say this is negative cosine of x. And I always have to take an extra beat, slow myself down, and double check that minus sign. The derivative of v should be dv. So negative cosine would go to negative sine. So u and dv I chose, and then I computed du and v. And now I'm just going to plug everything into my formula. So I have u times v. It doesn't really matter how bad that is because it doesn't need to be integrated. And then minus the integral of v times du. So I can do a little bit of cleanup, but start to notice that we have a very, very slight improvement here where you don't have this extra x running around. So it looks like almost the same level of difficulty, but because we've gotten rid of that x, this is actually something we can integrate. Okay, so let's do one step of cleanup. I'll make this negative 3x cosine x. This minus sign and this minus sign combine for a plus. And I'll make it 3 cosine of x dx, just so that it's pretty. That step is definitely not required, but it is a little easier on the eyes. Alright, so negative 3x cosine of x, that just comes down one more time. And then the antiderivative of 3 times cosine of x will be 3 sine of x plus c. And again, take an extra beat, double check whether a minus sign should be there. We're good, because the derivative of sine is positive cosine. And we're good, that's actually our final answer here. If you really want to double check your answer, you could take the derivative of this. I think to get all the way back here, you'd have to do some trig identity simplifying stuff, but pretty much we're good. Alright, so let's try one more example here. The next one we're going to do is x squared natural log of x. And again, you might try to think of a substitution first. Nothing really seems great. This is a really good candidate for by parts. Alright, so again, I'm going to kind of set up my 4 pieces. I need all 4 of these filled in to use the formula. And I want to choose the u and dv to be 2 pieces of this integrand here. So they should multiply to be x squared ln of x. In this one, there is a sort of obvious split where you have x squared and ln of x. Now, if I put x squared here as the u and ln of x here, the derivative of x squared would get a little bit better, right? We'd go to 2x and we'd technically have 1 lower power. But if I had ln of x here, then I would have to integrate that to get to v. And I, off the top of my head, don't know the antiderivative of ln of x. It actually is something that you can do using the tools of this section, but it's not like something we automatically know. So what we're going to choose here is ln of x and then x squared down here. And again, I'll include the dx to be polite. And it's actually going to work out kind of magical here. You may also find, in terms of deciding your u and dv, there's that like mnemonic device that the book uses, the Liate thing. Feel free to use that as well, and it should lead you to the same decision that I just made here. So let's try this and see what happens. Ln of x, its derivative is 1 over x. X squared's antiderivative is 1/3 x cubed. So now I have all 4 pieces, and I can apply my by parts formula to the integral. So I have u times v minus the integral of v du. Okay. So again, it doesn't really matter how messy this part is because it doesn't need to be integrated or anything. It's just kind of good to go. Here, we really are hoping that it becomes something that we can integrate. So as it is, this kind of doesn't look great. But the key is that x cubed times 1 over x, that can actually simplify, right? So this is x cubed divided by x, and you actually just get x squared. So let's take one more step here. So I'll have 1/3 and then x squared dx here. And we go, oh, that's totally something we can integrate. So normally, like in the example above here, I mean, I did some rearranging to make it pretty, but I didn't do any simplifying here. Every once in a while, particularly if ln of x is involved, this little extra simplification step is key. So slow yourself down here and make sure you're writing it as nicely as you can so that the integration step goes as smoothly as you can. All right, so our last step is to just actually integrate this. So 1/3 ln of x times x cubed minus 1/3. So this 1/3 just carries right down. The antiderivative of x squared is 1/3 x cubed. And I'll throw on that plus c. And I'm going to take one more step here and just simplify. I have, you know, two constants being multiplied here. I'll go one more step and combine them into a 1/9. And that is my final answer.